Let's try to determine the polynomial equation from a given graph. In other videos you have seen how we found polynomial equation from different conditions. This time we'll go from a graph to the equation. Now here is a graph given in red. It is for an octic function. Octic means degree 8. Now the question is to find all possible equations which will show this graph. All possible equations for this polynomial. Okay, so let's start with degree. The degree is 8. That is given to us. Degree 8. Now here we are given few zeros, and you can see from the graph that zeros are of different kind. This is odd degree, this is also odd but straight line, and this is even degree. So possibly the multiplicity or order of this 0 could be 3 or 5 or 7, but 7 is not possible. Since we are given degree 8, 2 more zeros will be more than 8. So possibly it could be 3 or 5. Here the degree is 1, it's like a straight line, and here it could be 2, 4 or 6. 6 is not possible because 6 plus 3 minimum will make it more than 8, right? So there are two options. So we'll go with those options. So let's start down our zeros. So what are the zeros? Zeros are at -6, -2 and at 3. Now what is their order? Order first possible is, let's take the first 0 as 3 multiplicity, okay? So let this be 3, and this is 1, and this will be 3 plus 1, 4, so this has to be 4, correct? Because then we get degree of 8, otherwise we don't get degree of 8. So that is first possibility. The second possibility is, let me write down that in red. We'll assume this to be of order 5, and this 1, 5 plus 1, 6, to get 8, this should be of 2 in that case, correct? So that is our second possibility. So this is our function 2, we'll write this in red, and the other one in blue, function fx. This is our function 1 and that one is our function 2. Now what are going to be their equations? Let's write down the equation. Fx, the blue one. So blue one function, first 0 is at 6 and of order 3. So it will be 6 plus 6 to the power of 3. Second one at -2 will give us factor of x plus 2. And third one, 0 is at 3. So the factor will be x minus 3 and the order is 4. This is the family of functions. But we are given a specific point. The point is at 1 it has a value -4116. So that will give us value of a, which we need to find. The other equation could be this red equation. Fx equals to a times x plus 6 to the power of 5 this time. X plus 2, this is a linear factor, and the other one is a quadratic factor, x minus 3. It's good to check. What is the degree here? 2 plus 1, 3, 3 plus 5, 8. Correct. 4 plus 1, 5 plus 3, 8. So both represents the octic function, which could represent our function. Now we know that the point 1, at 1 the value is -4116, lies on the graph. That will help us to find a. So let's solve for it. So in one half we'll do the blue part and on the other we'll do the red part. So let's start with the blue part, okay? Fx is equal to a x plus 6 q x plus 2 x minus 3 to the power of 4. 4, 5, 6, 7, 8. 8 is the order or multiplicity or degree, this time degree for a function. At 1, the value is this much. So let's put f of 1 equals to a times 1 plus 6. So what do? You substitute 1 for x. Correct? And f of 1 is given to us as minus 4116. 7 cube, 2 plus 1, 3, 1 minus 2 square. Let's calculate. 7 cube equals to 343. So a times 343 times 3 minus 2 square is 4. So 343 times 4 times 3 is 12. Let's multiply by 12. Equals to, oh sorry, this was not 2, this was 4, sorry, 4. So minus 2 to the power of 4 will be 16, not 4. 16. So let's do this. 343 times 3 times 16 equals to 16, 464. A. Correct? So what is A equals to? A will be equals to this number divided by this. So minus 4116 divided by 16, 464. So let's divide. 4116, I am not taking negative sign, I will put negative for A, divided by 16, 464, which is equal to 1 over 4. So we get minus 1 over 4 equals to A. So A is minus 1 over 4. Therefore, our blue function is minus 1 over 4 x plus 6 cube x plus 2 times x minus 3 to the power of 4. So this is an octic equation, polynomial equation, which represents our graph. Okay. Now let's try to figure out what's the value of A. Alternate equation. Now there also we'll plug in the same value of 1. So f of 1 equals to A times 1 plus 6 to the power of 5, 1 plus 2 times 1 minus 3 to the power of 2. Here A, 1 plus 6 is 7 to the power of 5 times 3 times minus 2 square. So what is f of 1? F of 1 is minus 4116. Now let's find 7 to the power of 5. 7 to the power of 5 equals to 8 times 16807 times 3 times 4. So we'll multiply this by 12 times 12 equals to, we get 684A. Now to find A, what is A equals to? A will be equal to minus 4116 divided by 201684. So let's do this. I'm not writing minus, I'm just saying 4116 divided by 201684 equals to 1 over 49. So we get minus 1 over 49 equals to A. Therefore, our function is minus 1 over 49 x plus 6 to the power of 5 x plus 2 times x minus 3 square. So these are the two equations which will represent our function. Correct? So let's review our process of doing the things. When we are given a graph, then first thing what we have to do, in this case the condition was also given that the degree is 8. So find where the zeros are. See, we got 3 zeros here, minus 6, minus 2 and 3. Possible multiplicity or order of these zeros, could be 314, which will add to 8, or 512, which also adds to 8. Now, the possible equations as per those will be the blue value, which we got from the first condition, fx, a, x plus 6 cube times x plus 2 times x minus 3 to the power of 4. To find a, we plugged in the given point and did all the calculations and found a as minus 1 over 4. So that became the first equation. Second time, we plugged in the value again into our second equation and found that a to be minus 1 over 49. So that became the second possible equation for our polynomial. Okay, so that's how you can find it. Second important thing is that a graph can be represented by more than one equation. Okay, fine. Thank you.